Hello everyone, good morning. Dear authors and invited guests, welcome to the technical session 8A. Myself Adesh Bazare and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for this session, Dr. B. Uma Maheshwari. He is an assistant professor in the Department of Computer Science and Engineering at JECRC, Jaipur, Rajasthan. With 14 years of teaching experience and 2 years of technical expertise, her skill set spans C, C++, Java, J2EE, .NET, and RPA technologies with numerous certifications, including in machine learning and network security. He has published around 20 research papers, authored a book on operating systems, and has 2 patents to her name. Now, I would like to start with the papers. We will begin with Mamik Patel, who will present his paper on advanced intrusion detection in networks through ensemble voting techniques. Mamik, are you in the session?
Yes, sir. I am in.
Okay, so you can begin with your presentation.
Okay, sir. Hello, everyone. Is my screen visible to you?
Yes.
Mamik, we are only able to see the taskbar.
Now, is it okay?
Yes, sir.
Okay. Hello, everyone. Myself, Marmik Patel. I am currently a student of Charoset University. Today, I will be presenting regarding the advanced intrusion detection in network through ensemble voting techniques. Basically, what is NIDS? NIDS is a network intrusion detection system. It protects you can see the organization from the internet threats regarding like the attacks, various attacks like DDoS, you can say brute force attacks, Hydra, etc. So what we did in this era, the increasing network traffic and complex cyber threats necessitate advanced NIDS. And we propose an ensemble-based NIDS using SVM, random forest, and KNN combined via voting classifier. So in general term, you can say we created a system just like the ozone layer, how the ozone layer protects the earth from the, you can say, the ultraviolet rays of the sun. Our net guardian protects the organization from the, you can say, the internet threats by creating a shield. It allows only the good packets and blocks the bad packets. And how we detect that? We use the KDD Cup 1999 dataset for to identify the malicious and as well as the good packets. And we achieved our astonishing the accuracy of 99.96%, ROC AUC curve of 1, and feature importance analysis highlights key predictors for enhanced detection, and the model demonstrates scalability, accuracy, and lays the groundwork for integrating the advanced deep learning methods in NIDS. The concept of using decision tree classification tasks, such as network intrusion detection, originated with the foundation work, simplifying the complex data classification problems. This laid the groundwork for advancement like statistical learning theories, by which provided a robust framework for analyzing the network traffic patterns. Traditional methods such as firewall and antivirus systems were found insufficient for modern threats. Why? Because they use the signature patterns and they were unable to, you can say, the compete with the current, you can say, more advanced attacks that are also known as the zero type vulnerability attacks that can happen to the organization. Old, like you can say, firewall and antivirus system were there, but they couldn't detect much as fast as the ML model can detect, and you can say the help us the organization to protect. A major challenge in the imbalance you can say intrusion data set was addressed by using the SMOT to generate a synthetic instance of independence classes. This study integrates these foundational insights, employing an ensemble-based NIDS, combining decision trees, random forest, and SMOT. Evaluated on the KDD Cup 1919 dataset, a widely recognized benchmark for intrusion detection research. This is a research, you can say literature review by the authors, which dataset they have used, what classifiers did they use, and how much accuracy did they get. Out of this, the summary is that the random forest demonstrated superior accuracy was 94.7% due to its ability to handle noisy data and perform effective feature selection. SVM showed a strong performance in high dimensional dataset, achieving accuracy between 85 to 92%. Smart balanced datasets, improving detection of rare attack types with 15% higher detection rates and 2% of false positives. Hybrid models like Deep Defense CNN based and LSTM CNN achieve high accuracy above 96%, particularly effective for complex attacks like DDoS. Proposed methodology. Objective: develop an ensemble learning based NIDS using the machine learning techniques. We use the dataset KDD Cup 1999. Main challenge was to address the class imbalance and achieve the high accuracy for both normal and the attack traffic. We use ensemble learning approach using the three, you can say, main two models that are the random forest and SVM, and we use the gradient boostings. Soft weighting. Each model provides a probability. Final prediction equals to average probability of all models. Our timeline, or you can say training pipeline, was training the data, pre-processing it, use this mode for imbalanced data, then feature selection, model training and ensemble learning, and model evaluation. Why did we use ensemble learning? We can generally use the direct, you can say, any of the method models, but why ensemble? Because in ensemble, it combines the strength of multiple models for higher accuracy. Also, it reduces the bias and variance, improving the generalization, especially as you can say, especially with the imbalanced data sets like KDD Cup 1999, model training and hyper tuning, random forest, n estimators equals to 200, max depth equal to 30, minimum sample split equals to 10, minimum sample leaf equals to 4. We use these things, these numbers in our particular model training. Support vector machine, linear kernel, C equals to 1.0 for regularization, gradient boostings, n estimators equals to 200, learning rate equals to 0.1, max underscore depth equal to 5. SMART, synthetic minority oversampling technique. Purpose. Its main purpose was to address the class imbalance by generating synthetic sample for underrepresented classes. Ensure that both attacks and normal attacks are equally represented for accurate training. Cross-validation. Ensure robustness and generalization of the model. Results and discussion. Model performance. Accuracy was 99.96% on the KDD Cup 1999 dataset. RCAC curve was 1, indicating the perfect discrimination between normal and attack classes. Confusion matrix analysis. Low false positive 8 and false negative 49. SVM. Minimal misclassification with very few false positive and false negative. When voting classifier correctly identified 29,174 normals and 1100, you can say 1,18,978 attack instance, only 10 false positive and 45 false negative. Precision recall curve. Precision 1 indicating the higher accuracy in detecting attack without false positive, and high recall ensures that the majority of the actual attacks are detected. Key insights. Ensemble learning outperforms the individual models in terms of both accuracy and generalization, combines the strength of random forest, SVM, KNN, and gradient boosting to improve the performance of imbalanced dataset like KDD Cup 1999. Random forest analysis highlights key features that influence attack direction, count, DDT bytes, and SRV count. Smart effectiveness. Smart help to balance the dataset, leading to improve the detection of rare attacks with the minimal false positive. Overall performance. The proposed ensemble model provides scalable, high accuracy, and robust performance, making it suitable for real-world intrusion detection scenarios. These are the graphs you can say we have achieved. Challenges and limitation. Class imbalances. Despite using SMOT, the KDD Cup 1999 dataset still exhibits significant class imbalance, especially for the rare attack types. Model complexity. Ensemble learning increases the computational complexity as it is hard to train. It requires lots of computational powers. Real-time detection. The current model may not fully optimize for real intrusion detection in high traffic environment, such as a large organization. Feature selection. While feature importance analysis were conducted, certain feature may still need refinement for the optimal performance. Scalability. The model may face scalability issue when applied to larger, more diverse dataset beyond KDD Cup 1999, that is CIC, CSE, IDS 2018. Conclusion and future work. The ensemble learning-based NIDS demonstrated 99.96% accuracy with one RCUC score, achieving robust performance in detecting intrusion. Smart effective address class imbalance, enhancing model performance on KDD Cup 1999 dataset. The combination of RF, SVM, KNN, and gradient boosting in voting classifier outperform individual models and provided a significant, you can say, scalable and high accuracy solution. Future work, we can include the DL models that are the CNN and LSTM for the better anomaly detection and handling complex attack perform. Real-time intrusion detection, optimize the model for real-time threat detection and faster response. Dataset expansion, test and refine the model on the larger dataset and newer attack types. Cross-domain application, extend the approach to other security domains such as IoT, cloud computing to enhance its versatility. Thanks to all these authors that have helped regarding the doing the contribution to the, you can say, NIDS and all the other related topics that I have found helpful, and I have added their references in my paper and as well as in the PPTs.
Am I audible?
Yes.
Actually, can you explain why you chose the particular data set?
Okay. Basically, ma'am, the NI, you can say the KDD Cup, KDD Cup 1990 data set was the first data set basically for the, you can see the ground, lay the ground foundational for our project, or you can say our research. Well, there are so many data set currently, you can say the CSE, CIC, IDS 2018, but they are too large. You can say around more than 100 gigabytes. For our research, we need something you can say smaller, but effective for the future work. So that's the reason why we use like a KDD Cup 1999 data set.
Have you tried any other supervised classifiers for your thing?
What, ma'am? Can you
Any
repeat?
other supervised classifier other than what you have explained, SVM and random forest? Have you tried any other classifier?
Yes, ma'am. We tried, but we didn't get the actual, you can say the proper accuracy, and we were facing some errors. So,
What are the other classifiers you have used?
ma'am, actually we were using, you can say the aside from the random forest, Rishi, can you tell them as you were in the coding part? Rishi, hello. Rishi, am I audible?
Okay.
Thank you, Mamit, for your presentation. We'll move to the next presentation, which is Pratyanankev. He'll be presenting his paper on AI for medical informatics utilizing ensemble machine learning classification for monitoring premenstrual symptoms and assessing the risk of depressive episodes in Thailand private university students. Satya, are you in the meeting?
Yes, yes.
Okay, so you can begin with your presentation.
Good morning, everyone. My name is Papanapam. I'm represent for my team to present an AI for medical informatics, utilizing assemble machine learning classification for monitoring premenstrual syndrome and assessing the risk of depression as episodes in Thailand for university students. So this is our agenda for today. Currently, mental health issue among women, particularly adolescents and students, have against increased attention at the international level. This growing concern is largely due to uh, hormonal fluctuation prior to menstruation, which are significantly associated with both physical and psychological impact. Uh, Premenstrual syndrome (PMS) and premenstrual symptom disorder (PMDD) are commonly observed conditions among women of reproductive age, especially students who are often subject to academic pressure, discrimination, and various social pressure. These conditions may result in mood swing, anxiety, difficulty concentrating, and even depression that disrupt daily functioning. Without appropriate care and monitoring, such issue care can escalate into chronic mental health problem or lead a high risk of addiction, substance abuse, or suicide tendencies. However, limitation available of a mental health professional in education institution, particularly at the community level post certifications. In this context, the integrate of technological solution present an effective alternative. Artificial intelligence, AI, particularly through machine learning, hold a great potential interest in the large volume of health data with extreme accuracy enabling of identification of individual risk factors. Therefore, the risk this result and the export application of AI to develop a ways of classification of PMS and PMDD alongside an assessment of depression risk among university students. The ultimate goal is to provide a proactive monitoring to that can complement counseling or therapeutic intervention in the future. For the primary objective, the first to examine the context factor to study enroll into for all students enroll in the private university in Thailand who are likely to experience PMS and are at the risk of developing the depressive symptom condition that often remain you recognize during the academic years. Second, to develop a resource classification model by applying machine learning technique with a particularly emphasis on ensemble method that integrate multiple models to enhance the accuracy of identifying the student group. The last to evaluate the performance of the proposed model in predicting risk level among university students using standard physiology and assessment to namely the depression anxiety stress scale that's 21 and premenstrual symptom screen tool for adolescents PSSTA. Collectively, is effective and contribute to the development of practical tool for the proactive monitoring, prevention, and sustainable mental health support of students in the future. For population and sample, this research was conducted among students of Bangkok University, one of the largest private higher education institutions in Thailand, with a total student population of approximately 14,347 individuals. Usually, participants use a certain employees simple random sampling based on the sample size determination table developed by Chrissy and Nolan, while a widely accepted method in social science research. According to the calculation, the appropriate sample size was determined to be 375, and within which are considered sufficient for conducting statistical analysis and developing artificial intelligence models. Data collection was carried out through an online question. Participants was entirely voluntary. Respondents were free to withdraw at any time. All response were treated with a strict confidentiality and anonymity in accordance with research ethics guidance. For the instrument, this research utilized two types of instrument. The first is data collection to was an online question developed in Thai language and divide into five main sections. The first is general information, biological data, mental health, premenstrual symptom screen using the premenstrual symptom screen tool for adolescents and the open-end feedback. For model analysis, the study applied external machine learning technique which combine multiple algorithms to improve precision, accuracy, and reduce bias. For six models were random forest, gradient boosting, ranking, extract classifier, voting classifier, stacking. The section of this two was intended to ensure effective and accurate risk classification of PMS and depressive symptoms with practical application for mental health monitoring in context of university students. For data interpretation, the data analysis in this study is divided into three main components to enable a comprehensive and systematic assessment of both the mental and physical health risk among the participants. The first part involved the analysis of the demographic and biological information of the respondents, including age, weight, height, menstrual history, and other general health data. Descriptive statistics such as frequency, percentage, and standard deviation were used to generate an overall profile of the sample group. For the second part, focus of analysis of the results from the depression and statistical scale, which
Excuse me, sir.
yeah,
So sorry to interrupt, but you have 2 minutes of timing to conclude your presentation.
excuse me.
So you have 2 minutes of time remain to
Okay,
conclude
okay.
your presentation.
Okay, thank you. Which are level of the person activity distress among the outcome are categorized? The third part is actually from the PSSTA to which we use to classify the severity level of PMS and PMDD. Finding of this section provide clear indication the student group were more likely to experience PMS and PMDD. Is the insight were subsequent use the input predictive modeling in the next study is in several interpretation that are across this according from the critical bridge between forensic analysis in the practical application for the identity for the in detail monitoring and risk prediction. For classification model, the research used simple cost validation technique This method involves dividing the dataset into 10 for equal parts. 9 parts are used for training and 1 part used for test. The process repeats for 10 times. That the development model was evaluated by field accuracy, precision, result, error score, and time efficiency. So for finding, the majority of participating students were around 21 years old with 51 to 60 kilogram high, 151 to 160 centimeter. Naturally, 54% of the students report have a sexual experiment. Regarding mental and physical health results from that assessment, so this is a analysis of the SSC and assessment indicator. For this question, oh, so for this question, the data analysis about the demographic characteristics of the students sample were consistently the population level 74 time even in the same age group at the time of age very high and mental history. Regarding overall mental and physical health in the majority of students is with normal level stress, anxiety, and depression. AI-based creative model, particularly those development using a simple learning technique, demonstrate the high accuracy and effectiveness risk classification. For the future world, the finding of this study clearly demonstrate that AI, particularly machine learning technique, hold the significant potential in monitoring and assessing mental health and risk of university students. Additionally, this is the key of recommendation is to promote the development of digital application for mental health monitoring system that can integrate the AI model developed in this study. These two should be cited for practical implementation at the individual organization institution level, personalized and proactive mental health care. So it recommended to expand the research into other population groups and test the model in the diverse real environment. In the other enhance accuracy, robustness, application capability and system across the different contexts. So I simply hope that the resources presented today will contribute to growing body of knowledge in the field of AI and particularly in this practical application with domain and medical and mental health. Thank you for your attention. Should you guys have a suggestion, I would be happy to receive a feedback for thank you in the further discussion.
What about your literature survey? What about your literature survey? What are the papers you referred for this?
Sorry, I can't hear clearly. Yeah, you mean what do for a survey or something?
Yeah,
Uh,
references. What you have referred for your research work?
for the research work. What what do I have for the research work? Right? Am I correct? Um, I we have got AI model for we have AI model for
Okay, thank you.
thank you.
Thank you. So we'll move towards our next presentation. Our next presentation will be P. Aruna will be presenting a paper on early prediction of student academic success.
Sir, am I audible?
Ma'am, yes, ma'am, you are audible. You may begin with your presentation.
Yes, sir. I have shared my screen. Is it visible, sir?
Yes, ma'am, the screen is visible.
Yes, good morning all. I am Dr. P. Aruna, working as an assistant professor in CIT, which is located in Tamil Nadu. And today my presentation is about early prediction of student academic success. And the agenda of today's presentation is started with the introduction, followed by literature survey methodology, models used, results and graph, and conclusion, and future scope. And nowadays, education institutions is made to collect and maintain vast volumes of heterogeneous data, which can be used for various analysis purpose. And there are techniques like data mining, machine learning, which plays a significant role in discovering the unknown trends and patterns of knowledge about education system and learning process. So implementing prediction algorithms in educational institutions has become very normal now. So it offers important insights that can help and guide institutions to make timely decision and changes leading to better student outcome achievements. The student success is one of the essential component to assess the quality of educational institution. The goal of this work is to predict the student success using machine learning techniques and give feedback to the educational institutions to improve the performance of the students. And machine learning predicts CGPA using semester-wise GPA trends, providing early insights for timely interventions. By identifying key success factors, it helps detect at-risk students, enabling proactive support and personalized learning strategies. Predictive analytics optimize resource allocation, ensuring efficient distribution of tutoring and mentoring services. Institutions benefits from data-driven decision-making, refining curricula and teaching methodology to enhance academic outcomes. This approach strengthens academic support systems, improves institutional performance, and ultimately boosts students' success. And so this is the slide which tells about the data needed for the student-related variables to predict the success of the students. And the data needed are the student score, students' grade, discipline systems, students' attendance, assignment. These are all the things we are going to consider for predicting the success of the students. And the problem statement is there is a need of helping mechanism for institutions and faculty to forecast the student success from the first semester onward so that we can improve the scope, improve the performance of the students in the upcoming semesters. So the objective is to predict the success of the student in educational institutions in terms of academic success and as well as the placement success using machine learning algorithms to enhance the quality of the educational institutions. The factors which impact the academic success of a student is we can consider his academic achievement, whether it can be the pre-university data, pre-admission data, university data. From the first semester onwards, we are going to collect the data. For the second semester, till the previous semester, that means we can take the first semester marks and his pre-university data to predict the academic state, that means GPA of his second semester. While in the second semester, using the data till second semester, and we are going to predict his success rate to the third semester. For each and every semester from the beginning, we are going to assess, we are going to predict the academic success of a student, and according to the prediction, we are going to give some extra teaching to the students, or we are going to change our methodologies of teaching, or we are going to concentrate the students who are on the risk state. And the second factor is student demographics, gender, race, socioeconomic status, like that. And we can take the student's environment, psychological factors of the student, and student self-learning activity. So these are all the factors which will impact the academic success of the students, which we are going to take for predicting the academic success of a student. And the models we are using here are random forest, decision tree, and support vector classifier. And considering random forest algorithm, an ensemble learning model which trains multiple decision trees and aggregate predictions, which provides high accuracy in predicting academic success across semesters. It identifies key patterns in students' performance. And regarding the decision tree, it constructs a single tree for classification based on dataset features, easy to intercept with clear decision rules, perform well but lacks ensemble strength. And regarding support vector classifier, which maximizes class margin for precise classification, performance was inconsistent compared to random forest and decision tree. And these are all the data collections from different sources. We are getting the data using the survey, and we are getting the data from the student university management system. That means which we are having in our college, using which we can get the details, personal details, and pre-university marks. All those marks will be taken from the university management system, and we'll get the semester marks from the controller of examination, and from the placements also. Also, we are getting the details. So these are the data sources from which we have got the data, and these are all the classification models. For using these classification models, we have compared the above algorithms and find the best suited algorithms for our environment. That means for our college environment, and we are going to use the cloud environment for storing the data and for deploying the cloud and for deploying the machine learning models. And so the methodologies used are random forest, decision tree, support vector, and data set which contains some CGPA, GPA. And the accuracy evaluation of different algorithms across 6 semesters reveals that both random forest and decision tree consistently completed excessive accuracy with ratings of 0.95 for all semesters in comparison with SVC. Based on the evaluation of F1 scores across all semesters, the random forest algorithm emerges the best choice. The average F1 score for random forest is 0.73, which is higher compared to decision tree average 0.70 and SVC's average of 0.49. Although both random forest and decision tree have comparable accuracy scores, random forest consistently outperforms in terms of F1 score, indicating a better balance between precision and recall. This makes random forest the most robust and reliable algorithm for predicting students' academic success in this context. For recall, random forest and decision tree both exhibit high performance, with random forest achieving an average recall of 0.7 and decision tree matching this at 0.97. And SVC, on the other hand, shows lower and more variable recall scores with an average of 0.81. And the random forest algorithm will be exceptional preference based on the recall scores, accomplishing a mean recall of 0.97, drastically higher than SVC's 0.81. The strong recall performance along with this robustness makes random forest the preferred algorithm for this task. Based on the assessment of precision scores, the random forest algorithm is diagnosed as the best choice, reaching an average precision of 0.888, which considerably surpasses the SVC's average precision of 0.65. Overall, random forest is the top performing algorithm, demonstrating superior F1 scores, accuracy, recall, and precision compared to decision tree and SVC. And this is the graph we have used for comparing our results. And conclusion and future score. The methodology predicts academic success based on semester performance. Future work will extend to placement prediction by incorporating extracurricular activities and internships with this academic success. And deep learning will enhance accuracy while real-time data integration and institution collaboration will improve adaptability and model effectiveness. And these are all the references we have used for our research. Thank you. Now open for question session.
Actually, other than his marks, scores, and attendance, have you considered any other factor for students' success?
Yes, ma'am. Actually, we have got the information from the UMS, ma'am, which will give his pre-university marks. And
That
also,
only, ma'am, you are always talking about only the marks, right?
yes,
If a
ma'am.
student is successful, only his marks decide his success, whether it can be university marks, yeah, whether it can be internal marks. What about his coding knowledge? Because you are talking about professional students, right?
Yes, ma'am. You are talking about the professional students. Marks plays an important role, ma'am.
It
Other
is a basic criteria.
yes,
So
ma'am.
other than for placement, marks is the basic criteria he should fulfill. What
Actually,
are the other things like hackathons, paper presentations,
that's what we have.
co-curricular?
That's what we have included in this student self-learning activities, ma'am. The number of login times, number of tasks he have completed, number of tests he took, and the number of
All these are taken within your university, right?
yes, ma'am. Yes, ma'am. Only for
Whether he went outside for presenting some papers,
no.
for
Actually,
participating in coding, that decide it's
hackathon also.
successful.
Yes, ma'am. Hackathon also we are going to include, ma'am. Hackathon,
Hmm.
yes, hackathon also we are going to include, which is not
But
in our university, which she is going to.
being professional students, their coding knowledge also should be tested for placement, right?
Actually, we are going to consider hacker rank. All these information will be collected, ma'am. Student self-learning activity. We didn't mention it here, but we are
Because
going
if
to
you are
consider.
doing only for your institution, then it will be easy for those data also easily available.
Yes, ma'am. Actually, we are considering only for our university in the future. So I mentioned that we are going to collaborate with some university in future.
Okay, ma'am. Thank you.
Thank you, ma'am. Thank you so much.
Thank you, Aruna ma'am. We will now move towards our next presentation. Our next presentation will be presented by Audumbar Londe, who will be presenting his paper on empirical study of aqua quality prediction techniques in distributed learning. Mr. Audumbar, are you present in the session? Our next presentation will be Satyam Das, who will be presenting his paper on financial data analysis using large language models.
Hello, am I audible?
Mr. Yes, Mr. Satyam, you may proceed with your presentation.
Okay, one second. Is my screen visible?
Yes, sir, it's visible.
Okay. Okay, so good morning all. My name is Satyam Das. I am a fourth year student in Vellore Institute of Technology, Vellore campus. I am currently pursuing my BTech degree in CSE, Computer Science and Engineering. Today I'm going to present my research paper, which is on the topic financial data analysis using large language models. So this will be the outline of my presentation. So starting off with the introduction and the motivations. So first we will address some limitations. So traditional stock analysis methods struggle with the real-time interpretation, sentiment extraction, and adaptive market prediction. So over here, this paper addresses these limitations by integrating the large language models and multi-agent AI systems for comprehensive financial analysis. The system autonomously gathers the financial data, performs sentiment analysis, and delivers dynamic investment advice using tools like Yahoo Finance News Tool and LangChain. Designed for both novice and expert users, it offers real-time, emotion-aware, and interpretable insights. The key innovation which lies in this is the graphical outputs, the bar and pie charts, detailed financial ratios, profitability metrics, sentiment line graphs visualize the market mood over this time, and the real-time stock price charts track the live market fluctuations. Then the predictive intelligence, these visualizations help the users to identify profitable entry points, assess stock stability, and validate the sentiment-based predictions. The system fills these critical research gaps in multi-agent reinforcement learning or MARL by incorporating the dynamic NLP-based sentiment analysis and market feedback, enabling timely and informed decision making. So next, this is the proposed system architecture, and this will be explained in the next slide. So the framework integration, how it works is the AI model uses something called Crew AI, where the multi-agent orchestration happens and it integrates Yahoo Finance News Tool via LangChain, enabling LLMs like GPT-4, which has been used over here, to autonomously fetch the real-time financial news for analysis. Then the forecast generation, over here, you can see this LangChain middleware is being used. It is incorporating the LLM and other custom APIs. So the LangChain enables LLMs to access the external services like Yahoo Finance, Newstool, other custom APIs, process financial data via NLP, and generate the instructions like forecasts or des descriptive insights for the informed analysis. And automated insights, the system uses LangChain again to fetch the real-time stock updates, processes them via AI, and presents insights as an interactive dashboard. So over here, this user input will go through a QA framework, and the LangChain middleware will use the LLM GPT-4 and other custom APIs, and also Yahoo Finance News Tool. And this whole uh, input will go through a data processing module, which will clean the data and it will provide the visualization, real-time stock analysis, and the GUI for the user. So the features and capabilities of this model is, so firstly, it has multi-agent system design. So the implementation of this architecture where every agent deals with a specific task. So there's something called financial analysis agent, which investigates the solvency of a given company by computing the significant ratios like P by E ratio, EPS, debt to equity ratio, among other ratios, and conducting a competitive benchmark for the firm ratios. And then there's this research analyst agent which collects and interprets the news, articles, press engagement, and stock related information with emphasis on the notable events in the stock market. For instance, the product releases and changes in the regulations, and it and can lead to shifts in the stability prices. Lastly, the investment advisor agent merges all this information and provides the investment advice. So some of the key elements for this interface is it understands the stock research, including the sentiment-oriented evaluation, and based on the stock prices and the graphical representation, a recommendation system has been made where the user can get the recommendation like either you can buy the stock or don't buy the stock or hold the stock. So the most important part of this presentation is a result and discussion. So over here, the input is the user can enter the company's name for whom the financial report and the analysis needs to be generated. And this is one of the sample financial report which is generated by the model. Over you can see it is taking Apple as a company. The price by earning ratio is here. The EPS ratio is here. The debt to equity ratio is here, and the dividend yield, gross margin, everything is there. So it is a detailed financial report which is created by the model. Now, what the user can do is the user can copy this whole financial report and paste it in the GUI, and these outputs will be made. So, firstly, this output, this is a bar chart. So it is showing Apple's financial health, with ROE is 27%, P/B is 28.5, shows strong profitability. So demonstrating the company's profitability, growth potential, and the liquidity. This helps the investors to discover good strengths like good cost management by Apple, and the weakness is the low dividend by yield ratio, low dividend yield. And it helps to assess the Apple's financial health and growth potential with the side-by-side comparison. So next is this pie chart, which is made by the GUI. It emphasizes the valuation centric performance like P by ratio or ROE account. So basically, what it says is what are the main two drivers of Apple's performance. So one is P by ratio, another one is return on equity. Rest are there, but they are not that significant for the performance of Apple. Next, another important chart is the sentiment line graph, which aligns the market optimism with the actual price surges, justifying buy, don't buy, or hold signals. So this line chart shows Apple's sentiment scores and why the stock market feel good or not factors such as earning report or product launch. And on an overall positive recommendation, it has buy. You can see it over here. So the peaks say positivity and the buying opportunities, and the troughs show the caution and help you decide whether to invest or not to invest. So sometimes this one is not that accurate. Sometimes it happens. So what the user can use is this real-time stock chart, which is extremely accurate and provides the insights for making decisions, especially when analyzing or adjusting investment choices. So over here you can see over a week time period, over 10 days of a time period, this whole financial graph has been made based on the surges on the prices or the troughs of the prices. So how it helps is it through the real-time stock price chart, it provides the important insights
Excuse me,
while
sir.
making, yeah,
I'll have to request you to conclude your presentation within 2 minutes.
yeah, yeah, yeah. Thank you so much. Uh, important insights for making decisions, especially while making the analyzing or adjusting the investment choices. So, um, all these things have been uh, explained in the previous slides. So how this whole insight works. So the platform resolves conflicting sentiments from different news sources using multi-agent AI system, integrating LLMs and sentiment analysis. A research analyst agent aggregates via Yahoo Finance Newsroom and LangChain, applying NLP models and weighted sentiment scoring on credibility, recency, and consistency. MAL is the continuously refines the sentiment interpretation and adjusting weightings dynamically. Discrepancy detection highlights contradictions, while the investment advisor integrates sentiment trends and financial data to provide balanced investment recommendations. So this approach ensures the adaptive and data-driven decision making mitigation, misinformation risks, and refining stock predictions through real-time AI-driven sentiment analysis. So, as a conclusion, we are providing a cutting-edge multi-agent AI-based stock analysis platform which leverages LLMs, RL, and NLP. On a primary benefit, this platform's ability to automate complex processes such as sentiment analysis, data visualization, and investment recommendations. So, this study is a significant leap in the area of AI-based stock analysis, guidance, and welcome to alternative and conventional financial research tools. And these are the references which I've used. Thank you.
Can you tell me how you have done your data pre-processing?
Yes, ma'am. So, over here we are using something called Yahoo Finance News. Sorry, now I'll just share once again. Yeah. So, over here we are using something called Yahoo Finance News tool in the proposed system architecture. So, over here, all the data which are coming from various sources are already there in something called Yahoo Finance News tool. So, over there, from there, we are actually incorporating all this data and we are processing through our all these LLMs and custom APIs. So, what
No,
LLM over here?
pre-processing. After applying LLM, you won't pre-process. Not exactly how you pre-processing is done.
Ma'am, pre-processing is already done by Yahoo Finance News tool, so we are not doing any pre-processing from our end.
So you already taking pre-processed data.
Yes, ma'am. Yahoo Finance News tool already pre-processes data,
But
keeps.
you should know now what are the components or what are the elements of this finance tool.
Yes, ma'am. The elements of this finance tool are is actually in form of table where there are P by ratios, debt to equity ratio, ROE, and then everything. And from
That
there, yes, ma'am.
that you should have showed in the slide. This is how we are doing that.
Okay, ma'am. Yeah,
Okay.
understood, ma'am.
What is the purpose of choosing LLM for this?
Yes, ma'am. LLM, what happens is, so all this data, all this table is going. So if a normal human being is seeing this table, that person might not be able to understand what is happening in. Basically, there are huge number of metrics. So LLM, what does is, it is acting as a natural language processor. So this whole data is going into LLM, which is GPT-4, and it is providing a textual output which a user can understand in a form of paragraph or more textual output. That is the main work of LLM over here.
So you are using everything which are pre-existing. Have you done any research on your own? Because you are
Yes,
taking the data from Yahoo Finance tool, right? And
yes,
you are
ma'am.
using GPT for a presentation part. Directly you are
Ma'am,
taking that. Huh.
we are not using GPT as like not like GPT in that sense.
How
We are
it
using.
works then?
Yes, ma'am, we are using GPT for API. So what this API does is, it provides us more access to textual outputs. So this table is first. It is what is done is, it is getting summarized in LLM. Then LLM is processing it and making it into textual output, which is going through this data processing module and visualization module, which is giving us the output over the GUI.
That's
So
what
we are
I'm
not using
saying.
GPT.
Everything, whatever you are doing, you should have clearly explained.
Okay, ma'am.
After LLM, applying LLM, data will
Mm-hmm.
be coming, how data is pre-processed. Then how
Okay.
we are making it as a visualize module. In visualization, how you are projecting it. Instead
Okay,
of
ma'am.
directly showing as a paragraph.
Okay, ma'am. Understood, ma'am.
You know?
Understood, ma'am. Thank
Okay,
you.
that's okay.
Thank you, sir. Now we'll move towards our next presentation. Our next presentation is Tirumala Rao Akurati will be presenting his paper on height horizons, leveraging machine learning to enhance adult height predictions from parental height. Mr. Tirumala, are you present in the session? Any co-authors for this paper are present in the session? Next is Poonam Nang, who will be presenting a paper on IoT-enabled cost-effective water pump monitoring system for crop irrigation in Indian farms. Poonam ma'am, are you present in the session?
Yes, I'm here. Can you hear me?
Yes, ma'am, we can hear you. You may proceed with your presentation.
Okay, just a second, sir. Just a minute, sir. I'm sharing my screen.
Yes, ma'am.
My screen is visible, sir.
Yes, ma'am, your screen is visible.
Okay, good morning, everyone. Myself, Dr. Poonam Da, and I am from GLS University. I'm presenting IoT-enabled cost-effective water pump monitoring system for crop irrigation in Indian farms. This presentation outlines an IoT-based solution to address the challenges of water pump monitoring and irrigation management in Indian farms. I'm covering following topics in this presentation. Before starting the research topic, I just want to know about the Indian agriculture system. Agriculture plays vital role in India, and 64, as we can see the statistics, 64.29% of the land is used for the farming in India, and that's showing that agriculture is major activity in the area. From this part, 63% of this farming land depends on the rainfall. And rainfall, we know this thing, rainfall is not consistent, it's irregular, and the irrigation system in place are not efficient. These problems lead to low productivity because most farming relies on rain, and current irrigation methods are not great. Using smart irrigation technology can help solve water and productivity problems. Now, problem statement is this: normally in farms, the farmers are using water pumps or submersible pumps on the daily basis to give the water to the crops. For that, they need continuous power supply. So to irrigate land, farmers got power supplied anytime during 24 hours of the day in village, because in India, in a village, there is no facility by 24 hours, there is no facility of electricity by 24 hours. So they will get the irregular power supply and that affects the irrigation management. So to address these problems, we propose an IoT-enabled cost-effective water pump monitoring system for crop irrigation. Challenges in this system, in existing system, farmers face several challenges in irrigation their crops, including irregular power supply. As I have mentioned, there is in villages there is no electricity by 24 hours. So farmers have to wait for the electricity. When it will come, then water flowing will be started in the fields, so time will be wastage. And for those things, for this monitoring of water and pumps, they have to place some labors to manage all this thing. So these issues lead to improper irrigation scheduling and reduced productivity. Addressing these challenges with IoT solution can improve irrigation management and crop yields. So we have proposed the IoT-based solution for this to solve this type of problems. So our system provides real-time monitoring of the electricity and the working of the motor. The when the Our system also provides the SMS or notification to farmers when the electricity comes and motor will be started. So this solution save time and labor, enhance productivity, and provides peace of mind for farmers. Already some of the authors have worked on the in the agriculture systems and provide the IoT solutions. there is a one author, they propose the IoT crop monitoring system for real-time monitoring of crop environment. They check the environment for the crops and provide the information to the farmers, so they can take the decision which type of crop they have to be planted or not. Then other author have created a automated switch, so that switches can be managed by the farmers by their mobiles, so they don't have to go to the farms and manage the all that switches. They have application they can use. So IoT helps like this in various areas to the farmers. This is my proposed architecture. The proposed system architecture includes sensors to monitor the water pump status. Here we have used the vibration sensor, which can give the status of water pump. We have used the microcontroller for data processing, and then we have used communication module for transmitting the data to the farmer's mobile. Farmers can receive the message with the status of the water pump, allowing them to know whether the motor is running or not, water is flowing into the fields. What are the benefits? So we can say the proposed system offers several benefits, like it's a cost-effective system. We have used some IoT components which are not very expensive, time efficient. So farmers don't have farmers don't have to wait for the electric. Don't have to keep the track. They automatically get the messages when the water is flowing into the fields and pump is started. And they don't have to use the labors. So it is reduce the dependency on physical presence. So it can also, even our system can be extended for more automation features, making it versatile solution for irrigation management in Indian farms. This is the implementation of our system. In this implementation, we have used vibration sensor. It is used to detect the operational status of water pump. The sensor data is sent to the Arduino. Arduino is an open source microcontroller which processes the information. If the motor is running, the Arduino triggers a GSM module, and the module send a message to the farmer's mobile
Excuse me,
phone.
ma'am.
Yes.
Yeah, sorry to interrupt, but I'll have to ask you to conclude your session in coming 2 minutes.
Yes. Arduino triggers a GSM module to send a message to the farmer's mobile phone, informing them that the motor is on and water is being supplied to the fields. We have used major three components. Arduino Uno, it's an open source board. GSM module for transmit the voice text messages, and vibration sensor to detect the intensity of the motor pump, so we can identify the motor is on. I can conclude this. Irregular power supply is a significant problem for Indian farmers. The system ensures timely irrigation alerts, promotes smart agriculture using low-cost IoT technologies. Is there?
No query, ma'am. No query from my side, ma'am.
Okay, thank you so much, ma'am.
Okay, so we'll move towards our next presentation.
Yes, sir.
So our next presentation is Anjali S. Jain, who will be presenting a paper on IoT-driven detection and monitoring of waterborne diseases. Anjali
Yes.
ma'am, are you in the session?
Yes, sir. I'm audible to you, sir.
Yes, ma'am, you are audible. You
Okay,
may
sir.
commence with your presentation.
Thank you so much, sir. Okay, my slides are visible now.
Yes, ma'am, your slides are visible.
Okay, so this is my topic about IoT driven detection and monitoring on mainly on waterborne disease. Like, firstly, I'm going to introduce the problem with that. The problem is like Indian surface water, like 70% of the Indian surface water is like unfit for the drinking purpose. Like, whatever the drinking we wanted to drink that particular water, that is not proper. Like, directly we cannot drink that. And majorly what happened, because of that many of the people are surviving with the cholera, typhoid fever, diarrhea. I'm mainly focusing on the waterborne diseases. And my topic is like, I wanted to like the thesis is going to, this project is about to identify waterborne diseases using IoT, sensor-based architecture, that we can say that. Okay, approximately this is the human, like this is the chart of the current chart of the this, like 30% of the fresh water is consumed by the industry and municipal corporations, like and about the requirement, like 60% of our body contains water and 90% of our blood contains the water parts. So that is like water is a major, we cannot live without them. So water availability, if I'm talking about water availability, 98% water of sea is available, only 2%. And in that 2%, only 0.036% water is available for the use. And remaining 1.96 are belongs to the polar ice caps and aquifer. So that is the problem. Like I have taken this data of 3 rivers which belongs to the Gujarat state of India, and this is the chart of the pH level. I have taken this data from the official websites, and this is out of range data, like from 2014 to I have covered 2022, which I got. And this much of data is the pH level is out of the range that is required. Same as the conductivity, the number of like again I have taken Mahi, Tapi and Narmada, the 3 rivers of that, and the same data with the coliforms. Coliforms is like major, like waterborne diseases are because of coliform bacteria, and because of that. So amongst all, like from 2014 to 2022, I have covered these 3 rivers, and I got this data that total coliforms are between this. And what is the like we want 0 per 100 ml, and this is the original data that I got from the report. So the problem is like the whatever the work sources come, that goes to the water treatment plant, where the where the treatment is done on the water. Then it goes to the trunk main, and from that trunk main it will going to the distribution center, and this distribution centers we got the water to the different houses. What happened if there is a leakage, if there is a pipeline leakage, like mainly pipeline leakage, then the bacteria can entered into the pipeline, and because of that waterborne disease occurs. So there is no way, like for the safety, like for the government purpose, whatever the distribution stations they are making, um so what is the plan is like this is the survey, this is the number of stations of Ahmedabad. I have covered Gujarat, Ahmedabad stations and all that. So this is the problem. Like what happened if there is a leakage and something? This is the chart of the Ahmedabad Municipal Corporation. So the proposed system, like this is the problem. Suppose this is the leakage over to this place, leakage over to this place, and connection is not working. So in that such case, who will be responsible for the water leakage, and who will be responsible for the disease that can maybe occurred? So there are primarily three problems. What would happen if there is a leakage in the pipeline system? The second is, what are the implications if water quality is compromised? Then what happen? And the third is, could this bring to large outbreak of waterborne disease? So this is my concern questions about the problem. So I have so far I have researched, and like these are the bacterias, virus, and microborne pathogens which are associated with drinking water. Okay, so mainly if I'm talking about this bacteria and bacteria and virus, algae, protozoa, and all that, how I so that currently there is no, like if I wanted to track monitoring day to day on the daily basis, if I wanted to track the system, like there is a lab test which is available, and through lab test you can generate that, and that also took
Excuse me, ma'am.
some time. Sorry, sir.
Yeah,
Yes, sir.
sorry to interrupt, but you have 2 minutes of time left. Please try to conclude in the
Sorry.
given time
Okay,
frame.
okay. I'm moving to the moving to my concept. Okay, this is the biosensors that I am talking about. Biosensors are working too. There. So mainly I have taken surface plasmon resonance biosensors, which is used to detect uh, bacteria. So this is my working model. Like first, we're going to take the samples, and from that samples through the IoT sensors, we can detect the parameters which are the different bacteria, which are the different protozoas along contains in the water parameters, and through the different matrices like daily monitoring matrices, we're going to judge that, and disease will be identified, and report will be generated to the person's mobile phone. So this is my proposed research work that I'm going to say going to. So this is the mainly about how I can be connect to that problem. So up till now, this is what I wanted to so these are the phases: IoT sensors, then continue monitoring to it, data analysis, and this is identification, then notification, and lastly report generation will be done. So these are my research work that I'm going to uh, done in near future. So that's it. Thank you so much, sir. I'm completing with my any doubt, any questions?
Yes, ma'am. Actually, you are talking about more on introductory part. Actually, you should explain what you are implementing and how you are doing it.
Okay.
You didn't
Sorry, ma'am.
talk about that.
I was not knowing, and I have taken much
And
of time.
whatever references you have given, most are up to year 2022.
Yes, ma'am.
Haven't started about 23, 24 and all.
Actually,
So
ma'am,
whenever
that
you are presenting some data, na, it should
yes,
be
ma'am.
very recent one.
Yes,
At
ma'am.
least some data from 24 or 23, because you are talking about
We'll make
current
sure that.
current
Sure,
issue,
ma'am.
right? So,
Huh.
but you are giving 2 years previous data means every, as you said, waterborne diseases are spreading in a faster rate means what is the present scenario we should know.
Yes, ma'am.
That's
We'll
all
look
from my
into it, ma'am. Ji, ma'am. Yes, ma'am. Thank you so much, ma'am.
Thank you, ma'am. Now we'll
Yes, ma'am.
proceed to our next presentation. Our next presenter is Mark Shah, who will be presenting a paper on scalable fraud detection in mobile payment transactions using leveraging machine learning techniques.
Hey, hi, I'm here.
Okay.
Yeah, let
You
me
may
share my,
proceed with your presentation, ma'am.
can you see my screen?
Yes, ma'am, your screen is visible.
Okay. You can see the presentation, right?
Yeah.
Okay. So, yeah, so I am Mehek Shah, and I'm going to present my paper on scalable fraud detection in mobile payment transactions using machine learning
Sorry to
techniques.
interrupt you, ma'am.
Screen is not visible for me.
Uh, uh, can you just
Oh,
reshare your screen?
yeah, 1 second. Is it visible now?
No, ma'am. We are just getting a message that you have started your screen sharing, but the actual screen is not visible.
Oh, let me try once more.
Yeah, sure. Ma'am, if you are facing any technical issues, we can take your session later. You can just ping me in the chat box regarding your issue.
Yeah. Yeah, okay. Yeah, I don't know why my screen share is not working. Yeah, I'll ping you like after the next one. I'll just figure it out. Yeah.
Okay. So moving forward, we have our next presentation, which will be presented by Prerna Agarwal, who will be presenting a paper on using machine learning to automate IT job role prediction by resume screening. Prerna ma'am, are you present in the session? Any co-authors for this paper, are they present in the session? Okay. Audumbar Londe, are you present in the session to present your paper on empirical study of aqua quality prediction techniques in distributed learning? Any co-authors for this paper? Tirumala Rao Akurati, are you present in the session to present your paper on height horizons, leveraging machine learning to enhance adult height predictions from parental height? Any co-authors for this paper, are they present in the session? Okay. So, respected session chair, it seems that we have only one presentation left of Mehak Shah. So we'll resolve the technical issue within 5 minutes and we'll start with the presentation, if it's okay with you.
Yes, sir, we can wait for 5 minutes. That's not an issue.
Okay, ma'am. Thank you. So we will call out the remaining presentations once again. Mr. Audumbar Lode will be presenting his paper on empirical study of aqua quality prediction techniques in distributed learning. Mr. Audumbar, are you present in the session?
Yes, sir. Yes, sir. I'm there, sir.
Okay.
I'm there.
So are you
Yes.
ready with your presentation?
Yes, sir.
Okay, so you may proceed.
Okay. Just a minute, sir. I will share my screen.
Yes, sir, sure.
Uh, hope my screen is visible to all. Sir, is it?
Yes, sir, your screen is visible.
Yes. Yes, sir. Thank you. Thank you, sir. So, today I'm here to present my paper on a topic empirical study of aqua quality prediction in aqua quality prediction technique in a distributed deep learning. So for the presentation, my outline for the presentation is introduction, problem statement, objective of the study, that is why the empirical study of the aqua quality prediction in distributed learning, and the literature review, and at the end, a point of summarization and what for this literature study has been done, and at last conclusion and the references. So at the beginning, the introductory part, that as we know that water is an important for all form of life in a, and it is a critical resources. We know that for the social and economical development and energy production, climate regulation and adoption, water has a crucial role. And due to that, we know that the aquaculture has a big impact on the Indian food economy, and it is a most important food for the many of the people. So it is necessary for some mechanism for monitoring the water quality in aquaculture also, and for the sustainable environment development. Water has a great importance. For that also, the water quality must be monitored continuously. So there are different systems, but the efficient and cost effective system is need to be monitored. The the aqua quality must get developed. So we know that the water quality can be examined using chemical, biological, and physical property such as turbidity, carbon dioxide, temperature, pH level, dissolved oxygen, phosphorus should be maintained at optimal level. And if we talk about the aquaculture, due to the food has been given to the fishes or whatever the seafood that we are culturing at the ponds, we need to give them some food, and due to that or due to the wastage from that, it gets the amino has been get generated, and we call it as the biofilm can be generated, and due to that the water get polluted. So to maintain that into the threshold level, we need the water quality monitoring system. But in a traditional water quality monitoring system, it has been observed that we are taking the samples from the river or lake or the aquaculture pond and examining them in the test centers. And in that, the time quantum from taking the samples and testing it in the laboratory, it has a period of time, and the quality parameters or the measures that we are going to check, it may get disturbed or it may get changed. And the result that we are getting at laboratory and the result we are getting at the real-time environment, it may be different. So due to that, some system to be get developed for the real-time aqua quality monitoring system. And recent advancement in IoT had led to the a smart water quality monitoring system. And due to the IoT, we can have the real-time data sensing by using the different sensors, such as the turbidity sensors, carbon dioxide sensor, temperature sensor, pH level, dissolved oxygen, phosphorus. All these are the important parameters. Almost 14 parameters are there that can be sensed by the sensors, and the immediate data sensing can be performed by using the IoT. But the traditional systems are central processing approach is developed, that all the data, huge data is sensed by the sensors, and that has been collected at the cloud or at the server. So the traditional process of the real-time sensing of the data is the centralized process. And due to that, it has some challenges and it struggles in that some of the areas, such as the scalability cannot be possible due to the large area. We can put it in the aquaculture pond, which will get the sense data for limited data. But if we have to check for the huge area to be covered for the sensing of the water, then it has the challenges or struggling for the scalability, latency, and computational efficiency at a central approaches. We know that the central approaches has the computational efficiency because the resources allotted at the server will have the high cost for performing that sense data. So the new approach has been developed, that is distributed deep learning, which enables the parallel data processing at the local level, and aggregation will be performed at the server level. So it facilitates the real-time analysis while reducing the computational burden on individual devices. Rather than coming all the data at the server, it will have the processing or processing of the data at the local level. We can call it as the cluster heads, and they will perform the processing, and aggregation will be performed at the server. So it optimizes the performance. Accuracy, again, there remains challenge for the due to the network latency, data heterogeneity, and the resource constraint at IoT enabled environment. We know that every IoT node has the less processing capacity, or the due to the battery it has, due to that it may have the less energy to perform that. So computational computing burden on that devices also may come. So this is the work which can be used for optimizing the performance. So the problem definition, by studying all this literature review, I came to conclusion for the problem statement, and I have defined it. This research is aimed to develop the optimization driven distributed deep learning framework to enhance the accuracy and efficiency of the aqua status prediction by integrating advanced optimization technique, incorporating adaptive learning mechanism to enhance the ability to handle the noisy, incomplete, or imbalanced data. So that is the main challenge during the processing of the central data, that is handle the noisy data, incomplete data, or imbalanced data. So here the study has been done for defining to develop the novel approach for aqua status prediction in IoT by proposing an optimization algorithm based on distributed deep learning classifier. So these are the two main objectives while studying this literature of around 25 papers we have studied, and the objective is that to make the comprehensive review on different state of art work and related to aqua status prediction using IoT and optimization, and to propose and design the optimization model based on this literature review. We are proposing an aqua status prediction model by employing the distributed deep learning classifier. So in a literature review, we have considered the key part. There may be a different aqua quality prediction techniques, but we have considered as per the our focus of study that distributed deep learning approaches, deep learning based approaches, and machine learning based approaches. We have divided the 25 papers in these three parts, and we have studied what are the advantages and what are the disadvantages of these papers. So in a distributed deep learning, we have selected almost 13 to 14 papers. In that, we can say that there will be a different methodologies used, such as the grasshopper optimization and Elman neural network, then fuzzy wallet neural network, federated learning based network, PSO optimized federated learning. So most of the times the federated learning has been used as a distributed approach. In a paper one, we can say that the cascaded SVM. Hello, sir.
Yes, sir. Sir, you have 2 minutes of time left. Please try to conclude your presentation in the given time frame.
Yes, sir. Definitely. I will come to the end within 2 minutes. So in a distributed learning, we have seen the basic distributed approaches such as SVM, ensemble, empirical mode decomposition, Gaussian Navi-based, Spark, ABC, BIP neural network. So most of the times in a distributed manner, we have used the deep learning algorithm, and the federated learning has been used for defining the distributed approach. Or we have seen that the map reducer is also the big data is handled by the Google with the help of map reducer. So map reducer based parallel algorithm are somewhere used in the neural network, also map propagation neural network, and in the genetic algorithm also. In deep learning approaches, we have seen the AdaBoost, the high frequency intelligence sensing network, and IoT integrated big data analysis with the real-time water sensing has been done. And in machine learning, the basic algorithm of LSTM and deep learning, wireless sensor with SVM, and AdaBoost extra trees has been developed. So these are some advantages and gaps we have found. And in a point of summarization, after studying the 25 papers, we have seen that some challenges has been faced for the traditional distributed deep learning and machine learning approaches. What are that approaches? So inadequate long-term prediction, sensor and model limitation. So in then data complexity and variability, high computational demand and poor interpretability, sensitivity to noise for missing data. So these are some challenges that we have taken into consideration, and we have defined the problem statement, and we came to conclusion that we have selected some publications based on the assessment to evidence of distributed deep learning based techniques are most frequently used approaches in paper. So Spark MLIP is considered mostly used toolset, and real-time dataset is mostly applied to the dataset in these studies. Furthermore, the accuracy is most important used parameter metrics. The above discussed complexity, what are the problem challenges we have seen, that will be resolved through the development of efficient distributed deep learning approach incorporated with the advanced map reducer framework, which will be used as a distributed network, which will have the vital road for conducting the precise water quality prediction. So these are the references we have studied. Almost all the papers we have taken. We have taken the paper from 2014 to 2024, and most of the papers, almost 12-13 papers are from 24. And we have started with searching the deep learning methodologies, distributed deep learning from 2014. So the review has been done with the publication of the year. The tool set has been used. The data set has been used. What are the parameters used for the evaluation of the waters, where they have concentrated, and where the feature selection has been done. So based on these 4 to 5 parameters, we have done the literature survey. And for that, we have selected the different papers, around 25 papers we have seen. And we have came to the conclusion that how it has been defined the problem statement for the next future work. So thank you. This is all from my side. Any question? I'm ready to answer.
Sir, this is
Please.
not only for this particular author. I request whoever presenting, just take care. You have to explain what you are implementing, how many papers you referred, what you studied in that papers, that should not be there. What you understood from there and what you are going to implement, how you are implemented, that is important in a paper presentation part. You are
Okay.
explaining introduction and literature survey for almost 9 minutes, and just
Okay.
by concluding, we couldn't understand what data set you have used, what is your
Okay.
methodology, what you
Okay.
have implemented. That is
So we.
that you didn't explain.
Okay. Okay.
So always take care what work you are doing. You have to explain that. You have to spend more time on that.
Okay.
If you don't explain your literature survey part this much elaborately, introduction part this elaborately, no one will question you. Also in literature survey, you haven't mentioned the year of the papers. Only in references you have mentioned it.
Yes.
But
Yes.
in literature
Okay.
survey, it is lagging. So which
Okay.
year
Okay.
paper, which study was done, what data
Okay.
set they have used, that is not
Okay.
explained there.
Yes. 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 Thank you for the suggestion, madam. I will take
Thank
care.
you.
Okay. Okay.
Okay, so we'll move forward towards our next presentation. But before going to our next presentation, I'd like to tell the remaining presenters that there is a given time frame for you all, and I request you to follow the time frame. You all have 10 minutes of time to present your presentation. At 8 minutes, I'll raise a gentle reminder. After that, you will have to conclude your presentation within 1 minute, so that we have ample amount of time for question and answers, and then conclude our entire session in the given time frame. Moving forward, our next paper presentation, Thirumala Rao Akurati, who will be presenting his paper on height horizons, leveraging machine learning to enhance adult height predictions from parental height. So, are you present in the session?
Yes, sir.
Okay, sir, you may proceed with your presentation. Just remember the time constraints.
Okay, sir.
Yeah.
Sir, screen is visible, sir.
Yes, sir, the screen is visible.
Okay, sir. Good morning to everyone. I am Trimulra from Vignan University, India. It is a pleasure to present my research paper titled Height Horizons Leveraging Machine Learning to Enhance Adult Height Prediction from Parental Height, submitted under paper ID 149 at the ICTIS 2025 conference in Thailand. This project focuses on how machine learning can help us predict adult height using the parent height data. Importance of the adult height prediction is valuable tool in both clinical and non-clinical settings. It allows pediatricians and doctors to monitor a child's growth, identify potential health issues early. From an athletic perspective, it helps predict physical development for training programs. It also supports research in hereditary traits across generations and can assist in identifying the malnutrition related growth deficiencies. And we are done literature review from past 5 years. We are getting some surveys on these papers. To understand the current landscape, we conducted a through literature review of previous research papers. These papers are previous papers, and these also we are getting some new papers to survey the problem. And our problem statement is the main problem we addressed was the lack of an accurate automated height prediction system using computation intelligence. Our objectives are to evaluate the impact of reprocessing like outlier removal and to compare the several machine learning models, SVR and linear regression, XGBoost, light GBM and artificial neural networks to develop a reliable and automated prediction system. This is a proposed methodology steps. First, we are collecting data and data pre-processing, data visualization. After that, feature selection, data splitting, model development, and model evaluation and comparison. The processing step is data collection. We are collecting the dataset, Galton dataset from the Kaggle, which is having 898 samples. Out of that, 481 are males and 417 are females. The source of the dataset is from Kaggle dataset, and the features in the dataset are family. Family means family identifier, which family it is, and father's dataset, father's height data, and mother's height, its number of children in that family, and their number, and the gender. It is representing if it is male or female, and height of the children. These are the features which is in dataset. Data pre-processing. After collecting the dataset, we are pre-processing the data. Firstly, we are duplicating the removals. If there is any duplicates or mismatched data or any in data type which is not having perfect data type, we are removing all that data. And gender encoding. In the dataset, there is only male or female in character wise M or F. We are converting that into numerical representation, male equal to 1 and female equal to 0, and we are finding the mid-parental height. For that, we are calculating by using formula father height plus mother height by 2, average of both parents, and after that we are performing outlier removal by using the interquartile method. And after performing the dataset pre-processing, we are storing the data in 3 types: original dataset before any pre-processing, and then after outlier removal and before outlier removal. In this outlier removal, we are using correlation analysis to remove the outliers. These 3 datasets are used to perform the models. After that, we are performing data visualization. These data visualization used to find out the outliers. Finding the outliers in the data visualization, we are distributing the child heights to father height and child height to mother height, and also individually we are distributing the data boy height and daughter height and son height to the father height and mother height. We are performing this to find out the outliers. This is the graphs we are representing. After that, we are performing correlation analysis, identifying the key relationships. This correlation analysis is used to remove the outliers. It improves the model efficiency, guides in selecting the most relevant features, reducing the redundant data, and enhancing the predicting accuracy. These are the tables describing the children's height related to father height and mother height, and also individually we are finding son height and daughter height to the father height and mother height for removing the outliers. After that, we are performing the model implementation. We implemented and compared several machine learning algorithms. Among them, support vector regressor emerged as the best performer. It helped nonlinear relationship efficiently and effectively, avoided overfitting through regularization. And then we are performing so many methods to prove that support vector regression is giving more accuracy. That models are linear regression and XGBoost, artificial neural networks, and light GBM. In previous papers, they are using old models. By this, we are improving our accuracy so that we are using boosting techniques and some more new technologies to getting best accuracy. Artificial neural networks are also gave strong results due to their layered structure and back propagation. Light GBM proved efficient for handling large dataset with the leaf-wise tree growth for higher accuracy. After
Excuse me, sir.
performing the models,
So your
performance.
time is almost about to end. Please try to conclude your session in coming 1 to 2 minutes.
Yes, sir. Yes, sir. Okay, sir. After performing the models, we are performing the error rate we are finding the error rate. So that we are using three methods: mean absolute error, mean square error, and root mean square error. SVR showed the highest accuracy after the processing. These are the result section accuracy tables for all models. The SVR is giving the best results, which is in bold. These are the error rate also there: RMSE and MSE, MAE. We are performing the F1 square precision recall, which is in confusion matrix to reduce the errors. This is the graph shows F1 square precision and recall for all the models, which is original data is represented with blue color, and before outlier removal is represented in green color. Red color is representing after outlier removal. For all the 5 models: linear regression, SVR, XGBoost, and light GBM, ANN. And to conclude, in conclusion, our study shows that machine learning, especially SVR, can substantially improve the accuracy of adult height prediction. Proper pre-processing, including outlier handling and intelligent feature selection, plays a key role in achieving the reliable results. This research not only supports pediatric healthcare and professionals, but also opens the door to personalized growth tracking system for families and doctors. This is the conclusion of our adult height prediction. Thank you for your attention. I'd be happy to take any questions now.
Other than SPR, have you done your research with this ANN models, as you said, and compared the
Ma'am,
result with SPR?
Yes, ma'am. We are finding ANN also, ma'am. Here. Got it, ma'am.
Yes.
Here
So
you can see
ANN
the
result is very good, right?
ANN also good, ma'am, but SVR giving highest accuracy and low error rate, ma'am. As you
Why?
see in
In your
table.
result, it is showing ANN only, na?
In results, ma'am, SVR is 94, ma'am. After outlier removal is the best thing, ma'am. Before outlier removal, ANN is giving, ma'am, but after outlier removal, 94, ma'am. 94% for SVR.
Accuracy value is good in ANN only.
Ma'am, in last column SVR, we can see that 11% for original data, 70.
How come it's so exactly which what you have applied to show that SPR is giving very best result? So generally, if you compare SPR with ANN will be giving best results, no? Because it is handling with neural networks.
Neural networks, ma'am, but
Okay, why you have taken outlier as a factor to compare the results?
ma'am, in some families, there is outliers means father's height are 6 feet, but in children's there is any issues, ma'am. But there is some short peoples are also there, so that's why we're using outlier removal, ma'am. In that family, father's height is perfect, but the children's are there may be any issues we don't know, so that we are taking that an action to remove the outliers, ma'am. Is there any issue or no?
No, I am not saying what made you to take outlier as a factor to do the comparison. That's all. Okay, thank you.
Thank you, ma'am.
Okay, so now we'll move towards our next presentation. Our next presenter is Mahek Shah, who will be presenting a paper on scalable fraud detection in mobile payment transactions using leveraging machine learning techniques. Ma'am, are you ready with your presentation?
Yes.
Okay, you may proceed.
Yeah.
Ma'am,
Can you see my?
Yes,
Yes.
the screen is visible.
I request you to start with your literature survey, ma'am.
Oh, okay. Okay, so for our literature survey, we read all these papers. These are from 2023, 2024. And out of all these papers, the major conclusion that we drew was that For fraud detection, there were mainly three things being used. One was XG Boost, but a major flaw with XG Boost was that it was not very scalable, because every time we were making decision trees on top of decision trees based on what was the fault, like what was the problem with the first one. So we were incrementally making decision trees. So it was not very scalable. The other models that were used were ensemble models. They delivered very strong results, but then they required extensive computational resources, because we are using multiple models together to reach a conclusion. Also, blockchain integration was done, but then blockchain in itself has infrastructure complexity. So all in all, these three models were explored, but they had their own disadvantages. So for our paper, we started with PaySim dataset. It's basically a simulated dataset which has over 1 million transactions, and it had multiple features. One, like for example, what was the transaction type, whether it was let's say a buy or a sell, or sending money, what was the amount, what was the destination account, what was the source account, and whether it was fraud or not. So, but the problem with the data set was that it only had fraud cases which were 0.13%. So we had to apply techniques like SMOTE, which is to create synthetic fraud samples. So we had to apply the technique to actually make the data set balanced, and there's no bias towards legitimate transactions. Our pipeline included the data collection, which is the PaySim dataset. We also removed duplicates. We handled missing data by injecting the mean instead of empty values. Again, applied SMOT, min-max scaling for normalization. We had 80% of training data and 20% for testing. And we evaluated multiple models like random forest, SVM, logistic regression, and naive Bayes. And the evaluation was done based on multiple metrics, for example, accuracy, precision, recall, AUC, and F1 score. So yeah, this is what the data looked like before we sampled it again to have more fraud samples as well. So yeah, as we evaluated these four models, I'll give a very short description of what these models are and how they are more beneficial and in which cases. So for random forest, it delivered the superior performance as it combines multiple decision trees. SVM was effective, but again, it's less scalable for large data sets. Logistic regression was simple and fast, but since it's not very good with complex fraud cases. Knife Bayes was also fast and simple, but performed poorly due to because Knife Bayes has this inherent assumption that features are independent, but that is not necessarily true in case of fault detection. So all in all, random forest emerged as a most effective solution in our case. So we had 97.59% accuracy, 96.3 precision, 97% recall, and 98 was our F1 score. Also, if you see the ROC curve, the area under curve score was 0.95. The best is 1, so we are very close to 1, which is a good thing. So this ROC curve and AUC also confirmed that random forest maintains high precision, even at higher recall rates. So the key insight here is that by achieving minimal false positives and maximum fraud detection accuracy, random forest is the ideal model for scalable fraud prevention. Again, we can just have a glance over the various models that we evaluated and the various metrics we had. I have already told about random forest. SVM just gave 66.3% accuracy. Logistic regression 83%, and knife base was the weakest one with just 60% accuracy. So there are key discussion points that I want to share about random forest. So by combining multiple decision trees, random forest actually minimizes overfitting and hence ensures better generalization. Also, random forest naturally, because of how it is implemented, ranks feature importance, and it helps identifying key indicators of fraud. For example, unusually large amount or sudden charges, or some accounts which are from different place, from a very different place of what we usually use. So yeah, and so yeah, these were the metrics that we used. I would probably skip the explanation of what these are. Um, so yeah, in conclusion, random forest was the best performer, and for future, I think for fraud detection, and we definitely need explainable AI. We want to definitely pinpoint what were the features that exactly triggered that fraud detection. So there are ways to do it, like using Sharp or Lime, so that we can figure out what was the main feature, or what happened exactly that triggered that detection. Again, we discussed the blockchain in our literary survey, so we want to explore further on blockchain, how it can be made more less infrastructure heavy, because distributed ledgers can increase and enhance the security and transparency during digital transactions. Apart from that, we want to explore more on hybrid models. Uh, we can combine random forest with neural networks, if there is any way to do that, and if it increases accuracy. So, and last but not the least, these are the references that we used. Yeah, that's all from my side, and I'm open to questions. Thank you.
No query from my side.
Thank you.
Okay. So now we'll move towards our next presentation. Our next presentation is Prerna Agrawal, who will be presenting a paper on using machine learning to automate IT job role prediction by resume screening.
Hello.
Hello, ma'am.
Yeah, am I audible?
Yes, ma'am, you are audible. You may
Yeah.
proceed with your presentation.
Yeah, sure. Thank you. Is my screen visible?
Yes, ma'am, your screen is visible.
Yeah. Good morning, all of you. This is Dr. Prerna Agrawal with co-authors Dr. Savita Gandhi, Vidhi Dattani, Darshan Raj, Mahek Rathore, and Khushi Vade. Today, I'm there to present the topic of my research paper, that is using machine learning to automate the IT job role prediction by resume screening. So this is my roadmap basically. We are heading towards introduction, then we'll discuss the proposed framework of resume screening. Then we'll discuss about the data set use. Then we'll discuss about the experimentation methodology, some results analysis, and the last part will be conclusion and the future work.
I
So,
request you to start with your framework.
yeah, ma'am. Okay, fine. So basically, just one line for the introduction. Right now, manual screening process basically is very much loadsome to recruiters, and again, it spends more time. So here, the solution for some automation in the resume screening was needed. So we have proposed that resume screening framework. So this is the basic resume screening architecture. First of all, this is the architecture diagram. We have developed a architecture that is having two domains basically. It is having the user portal as well as it is having the admin portal. So here you can see the main processes or the key components basically includes the verification requests, uploading of files, and reading the reports, and maintaining the data set. So here the process flow goes like that. User the process flow includes that the user will have the user authentication and validation process, where the user again can initiate the process of submitting and verification request. After it's done, the user will be moved to dashboard for further actions. Then the user can again upload the file, that is upload the resume, get the reports done, get the checks done, and again the user in the return will get that uh, I think which position is suitable to him for entering into, or which job role is suitable to him for entering into the market. Again, here we have the admin portal. Admin portal again can log in, go to the dashboard. Now again here the admin can have a manual CV upload as well. If the admin also wants to check for an employee or for hiring process, he or she can also upload the resume and again check that this current resume is suitable for which IT market position. Again, here in the architecture, we have the data set cleaning, that is pre-processing, key extraction and cleaning. Then we have machine learning process, which where we have used NLP and NLTK toolkits, that is natural language processing, and NLTK toolkits for exclusion, for extracting the key components from the data sets, like the keywords from the data sets. Fine, and we again have taken a ready-made data set from the Kaggle for building this system. So this was all the architecture about resume screening. Again, we have the workflows of user and admin side, as we have the two sides in the system, user and admin portal. So here the workflow of the user begins that the user will be entering the mobile number and the register to register in the system. Then the OTP will be generated and provided to the user. After the verification of OTP into the system, the user is successfully registered. Then the user can submit the CV, obviously his or her CV, for further processing. The CV should be less than 4 MB. Right now we have kept the criteria for verification, like the CV should be less than 4 MB size. So after uploading the successful CV, the text extraction again is performed from the CV using NLP techniques and machine learning, and the clean data is basically obtained. So after the extracted data is then compared with the data set using the machine learning algorithms, and the final screening results are obtained. Then the user again will receive the report of the final screenings and the findings. So this is the basic user workflow. Now this is the admin workflow. So again, admin will enter username and password for logging into the admin portal. So after successful authentication, the admin again will be redirected to the dashboard. The admin will manage all the data in the dashboard. Now again, the admin can also perform resume screening manually for any of the user. So again, the admin will submit the user CV again, that it should be less than 4 MB. So after uploading the CV, same text extraction is performed from the CV, that are the main keywords using NLP techniques and machine learning, and the key data is extracted. Again, after the key data is extracted, it is compared with the data set using machine learning algorithms, and the final screening results are then returned to the admin. So this is basically the user workflow and the admin workflow. Now, the data set which we have used to build this system is
Excuse
used
me,
from the
ma'am.
Kaggle. Yes.
Yeah, ma'am. You have 2 minutes of time left, so please try to
Okay.
conclude your
Okay.
presentation.
This is the resume screening dataset which we have used. It is taken from the Kaggle. It is having 1,440 records and 48 IT job categories. So here a diagram presents. This is the diagram that represents different 48 categories which will be used, and these categories are right now trending in the IT market. So this is the dataset which we have used. Now this is the resume screening dataset features. For example, our dataset goes for feature name, possible values, and data type. So we have category and we have a resume. So the data set taken from the Kaggle is having some structure like this. So it will be having a basic resume, and then our resume will be uploaded, and then the using NLP techniques, the key extraction is performed, and the data set is our the resume is compared with the data set, and the final results are given. Now, this is basically the experimentation methodology. The web application of the user and admin portal incorporates MySQL database at the backend. The front end is designed in React, and the backend is designed with Flask and using machine learning. So, for the training and testing process, we have divided the data into 80% training, 20% testing, and we have used different supervised and ensembling algorithms for the results, that is naive Bayes, random forest, decision tree, logistic regression, KNN, gradient boosting, EDA boost, cat boost, and light GBM and extra trees. Now, this is obviously data pre-processing. So before training and testing, we have pre-processed the data using NLTK toolkit to remove unnecessary elements like URL, special characters, non-ASCII sets. Then stop words are again filtered out. Then the unique column categories were again represented by an ID with a number. Then all these map categories, 48 unique categories, were represented by each by an ID. So after the data cleaning process, we have used machine learning algorithms on that. Now this is the user GUI of resume screening, the client GUI or the user GUI, where the user will upload a file and user will get some results. Like for example, this is a user resume where a student or any user will upload this kind of resume, and in the right side we there are the results. Like our system will give this kind of result. For here, for example, a user resume for Siddharth Parmar is uploaded, and the screening results are like the predicted job category for him is currently the software engineer. Fine. So this kind of input and output will be given by our system. Now, the evaluation criteria for our machine learning algorithms are accuracy, recall, F1 score, AUC, kappa score, and precision. Now, these are the performance results used for various algorithms, and here our performance result shows that two algorithms, that is CatBoost and Light GBM, works best and gives highest accuracy of 0.9792 and the AUC score of 0.999, which is around to 1. Now, this is the ROC curve of the whole, all the algorithms that we have used. Again, here, Light GBM and CatBoost performs the best. Now we again have compared our system with other resume screening systems as well, existing resume screening models. We got three resume screening models, and this is our resume screening model. Again, here the comparison clearly shows that the CatBoost and Light GBM in terms of accuracy performs very good enough, that is 97.92 in comparison to other systems. The other systems have got 99.6 and 99.48 as the highest accuracy. So our accuracy also matches around to that accuracy. So it can be considered as a scalable system. So this was the comparison of our system with some other systems. Now, based on the conclusion and future work, so here again, we have provided a general workflow for both resume screening for both users and administrators. We have again proposed here a resume screening architecture. Again, we have implemented that resume screening architecture. Now, to demonstrate the dataset's efficacy, again, we have implemented ensembling algorithms and different NLP techniques. So, again, we have represented ROC curve. We have given the performance findings, and with the evaluation of our algorithms, it clearly indicates that CatBoost and Light GBM performs exceptionally well for resume screening dataset for IT job role prediction to automate this process with the AUC value of 0.999 and accuracy of 0.9792. Again, the comparison study shows that in the terms of accuracy, that is 97.92, our system is highly scalable to can be used in real world market. So the future research can be can be concentrated on like more IT roles can be added, more skill set can be added, so that to the data set, so the system can become vast for more types of job prediction. Again, the resume data set can be extended to other domains also, like currently it is for IT, so it can be extended to other domains also. It can be a hybrid system also, fine, for the job role predictions in the future. So these are the references, and thank you so much. Any questions?
Yes, ma'am. Actually, Instead of Kaggle dataset, have you tried with any other sample dataset?
Yes, ma'am. The Kaggle
Mm.
data set actually was taken initially, but in that data set also we have added our own records as well. So it is not a pure Kaggle data set; it is a hybrid data set. So manually records are also added. Sample data is also added to that Kaggle data set for good performance.
So how many total records were there you are
One double
considering?
1440 total records for the Kaggle and our data set, and 48 unique job categories.
So what are
I
the main parameters you are considering?
I am considering the main parameters as basically recall, accuracy, and AUC.
Not for result, ma'am. From the dataset, what are the main
That main
parameters?
parameters, ma'am, I'm considering is the keywords. Keywords is like skill sets. You can see here the skill sets. The skills here it is given. So I'm considering that from the data set, the skill sets I'm considering from now based on the main
Only the
set.
from the resume, the skills only you are considering
No,
for
from skill sets
uh,
as well as the projects as well. The whole resume, ma'am. The projects have been done, the skill sets have been done, the
how feature
years of
selection
experience.
is done. You haven't showed na in your thing. So I asked,
What, ma'am?
what are the features you are selecting from the resume that should
Ma'am,
be somewhat
ma'am, the features I have clearly shown here. It is category and resume, and the resume here is the whole resume
all the
only.
resume will not be in the same format, right?
No, ma'am, you can
Hmm.
upload any resume. It is not like
Huh,
that.
huh.
This is the data set
So
resume.
if I
This
am
is the
uploading the resume,
yeah.
then based on some keywords, it has to take the data,
Yes,
right?
ma'am. It
So
will
that
basically yeah.
keywords you should have
Okay.
mentioned somewhere.
Here, ma'am. Here, for example, one resume is added. So here the
Mm.
skill sets will be there. Here the projects will be there. So before giving the data set to the machine learning, whole NLP, NLTK toolkit and natural language processing is being done. And the stop words or the main words like skills,
That
project,
is data pre-processing we are doing with NLP. It
yeah.
is not extracting the features, right?
Ma'am,
Only
after NLP, after the data processing, it will extract the features and it will create the whole physical
how
file.
data features are extracted.
Ma'am, using see this is there. Column categories are again transformed. The whole 48 categories. Then mapping of that whole categories is being done by ID. And in the data set, we are extracting the features using the algorithms from the label encoder
Which
library.
algorithm?
We are using label encoder library, ma'am. NLTK tool we
Library.
are using.
This you are implementing using label encoder.
Yes, yes.
But which algorithm you are using to implement the features?
Uh, we are using, ma'am. We are creating the whole. We are pre-processing it, and
We are giving resume. We are pre-processing our resume. After
yes,
pre-processing
we are
using
using
NLP,
sklearn pre-processing, and after the data, we are going for the categorization process.
how you are doing that categorization?
Uh, using the uh,
Because the
using
resume
the
won't have the
vectorization.
same
Using
that
the
you have been
numerical features, the clean data set then is transformed with TF-IDF
that's what you
vectorization.
haven't shown properly. That's what I say. You just
Okay,
showing from the resume. We are
okay,
taking from how you are taking from the resume because it is not all the resume will not be in the same format. Some will be explaining in tabular form, some will be in the paragraph form, some may skip the projects, some may have the projects. Okay,
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 okay.
ma'am.
So
That's
here, ma'am,
what we can
basically
do.
we are going for the skill sets. You can see here in the resume report, we are normally going for the skill sets and the technical words.
Okay, ma'am.
Okay, thank you, ma'am.
Sir, are you there?
Yes, ma'am. I'm
Mm.
sincerely apologize. I had a technical glitch right now. So yes. I sincerely thank our authors for the excellent presentations and contributions in this session, and all our participants for being a part of this international conference. The session 8A has concluded, and I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chair, Dr. B. Uma Maheshwari, for chairing this session.
Thank you, sir.
Yeah. This is a token of appreciation to the chair on behalf of team ICTIS 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Ma'am, I would like to give you a concluding remark.
1 sec, sir.
Yes, ma'am.
I would like to thank all the authors for the wonderful presentation. The authors are from all over India, and they have provided insight on various topics. They have covered IoTs, they have covered machine learning. So it's a very good session from my side. They have put their whole soul effort in presenting the paper. In that, even BTech students also presented, and some research scholars also presented, and even doctors also presented. So it is a multi-level presentation, I can say in simple words. So in that, I would consider the VIT thing they have presented very well, and also that IoT part title presentation, that is how the water pump is managed. I consider these two as a very good thing, and also one more I want to say, one more project. Um, like a scalable fraud detection. I consider these three as that is they have followed the exact flow. They because other projects, other papers also were presented very well, but considering the flow, I consider these three has a very good flow. That is, they started with the main thing, how they have to present the thing. So please, others, take this as a note and take care while presenting in the remaining papers presentation, that you need to put more effort on explaining what you have done rather than going more on a literature survey part or introductory part or a conclusion future scope. So in the stipulated time, try to present your work as a main thing. That's all from my side. Anyhow, I enjoyed the presentation, and I thank everyone for their effort in making this presentation a success.
Thank you, ma'am. Now I
Thank
kindly
you.
request you all to switch on the camera for a quick snapshot of the virtual conference. It's a request to all the authors to switch on their cameras. Okay. Thank you all. Stay safe and take care.
Thank you, sir.